This is the desktop of the Qubes operating system. This is the best desktop operating system to enforce security through isolation and compartmentalization, in my opinion. It is still in its early days for the operating system, but the concept behind it is excellent. Qubes is a free and open source operating system designed to provide strong security for desktop computing, not for servers. Qubes is based on the Xen hypervisor, the X Windows system, and Linux. It uses virtualization to enforce security domains through isolation and compartmentalization. This is good because virtualization reduces the interfaces between security domains but still allows the security domains to exist and communicate. Perhaps the best way to think of it is as if you're running on your laptop a Xen bare metal hypervisor with some Linux kernel added and additional code to handle communication between those virtual machines, plus some added security features. That's Qubes. The user environments, or the individual VMs, are based on Fedora, Debian, Arch Linux, Unix, Microsoft Windows, and some others through what are called Qubes templates. It's an operating system like any other that you download and install on your laptop or desktop, although it does take about 3 hours to install. It's quite a beast. At the moment, this is the latest version to download, and there's also a live CD version that you can get, which you can download here if you want to try it out. The live CD currently, as I'm recording, doesn't have the latest features as the full install version, but at least with the live CD you can test it out and see whether it works on your hardware. Note, I haven't found this live CD, or in fact installing it, to work on virtual machines, on any virtual machine, so you'll have to try it on bare metal. Let's talk about kernel design for a minute. So most operating systems, Unix, Linux, BSD, use a monolithic kernel architecture, which means lots of code runs with high levels of privilege, or what is called the Trusted Computing Base, or TCB. The TCB is all the hardware, firmware, and or software components that are critical to a system's security, the Trusted Computing Base. If security bugs or compromises occur inside the Trusted Computing Base, it is very likely to jeopardize the security of the entire system. Vulnerabilities in the kernel are especially dangerous, so avoiding kernel vulnerabilities is especially critical. Now, what you can see here, these are examples of monolithic kernel TCB components that you have to trust are good. These make up the attack surface of a monolithic kernel. So the smaller the Trusted Computing Base, the better for security, the smaller the attack surface. So why is this relevant to Qubes? Well, unlike VMware and VirtualBox, which runs directly on a host operating system like Windows or Debian, Xen, which Qubes is based on, is a Type 1 or bare metal hypervisor. Qubes uses a microkernel as the isolation enforcing code, reducing the attack surface. Less code equals less potential security bugs equals less potential compromises, or at least that's the theory. A good theory though. An attacker must be capable of subverting the Xen hypervisor itself in order to compromise the entire system, which is more difficult to do than subvert a host on a Type 2 virtual machine like VMware and VirtualBox. There is no full host OS to compromise with a Type 1 hypervisor like which Qubes uses. This is an advantage for security which Qubes has over VMware and VirtualBox. Let's talk through the system architecture and the various VMs. Qubes enforces security domains through different virtual machines that establish isolation and compartmentalization. Each of these boxes here represent different virtual machines and different security domains. No host operating system is used, as Xen is the bare metal hypervisor. So first, let's look at the Xen hypervisor and administrative domain, or the GUI domain, which is this one here. and this one here within the interface. The host domain, or DOM0, is the interface or GUI to everything else. It's what you see when you are logged in. DOM0 controls the graphics devices as well as input devices such as keyboards and mouse. DOM0 is what shows what you're seeing now, this desktop. It is used for running the X server, which displays this user desktop, and the Windows Manager, which allows the user to start and stop the applications and manipulate the windows. Critically, and for security, DOM0 has no network connectivity. It has as little communication as possible with other domains in order to minimize the possibility of attack from a compromised VM. As you can see, it uses KDE by default, and even, for example, if there was a bug in this KDE, DOM0 isn't reachable for an attacker as there is no network connection to it. You can just view it, in effect. Because the DOM0 doesn't have network access, only a few components need to be updated, which the administrator can install at the command line. To view applications running in each VM's domain, Qubes provides the application viewer. This provides a false impression for the user that applications execute natively on the desktop, as you can see here, but they are in fact applications running in separate VMs. Like this window here, you can see the yellow window with a yellow border. This is running in the personal virtual machine. And the green window here is running in the work VM. But because of DOM0's application viewer, you have the false impression that these are just separate windows within an operating system, but in fact they're entire separate operating systems as part of a virtual machine that are isolated from each other by Xen and Qubes. There is a network virtual machine, or NetVM, which you can see here, also represented in this diagram here, NetVM. Networking is performed in a separate VM, which is great as the network layer is a critical component for securing communication. This VM protects you against exploits against things like your Wi-Fi or Ethernet driver, protocol stacks, or maybe your DHCP client. And you could also use this to isolate your VPN and make it available for other virtual machines. So what I mean by that is the network VM enforces a VPN and your other VMs are tunneled through that. This prevents leakage. Remember the nightstand from the NSA ANT catalog? If, as advertised, if we imagine this has some Wi-Fi driver or protocol stack type exploit that it's able to perform, if you're using a normal operating system like Windows, Debian, OS X, Linux, it's game over if they have that type of exploit. With Qubes, because the network is isolated in a VM, only the network VM would be compromised by an exploit like that. The attacker would have to escalate his attack to get to the other domains or other VMs. So it's a great idea to have your network as a separate virtual machine as well. In fact, it would be great for all operating systems. This does require that your hardware has IOMMU, also known as Intel VTD. There is a firewall VM which enforces firewall rules between the network VM and other domains. So you can configure the protocols, the sources, the destination, etc. for the communication between the domains. There are disposable VMs. So the disposable VM, like the name suggests, will dispose of the VM once it has been used. It is typically used for a single application like a viewer, an editor or browser. You can open a suspicious attachment with complete safety or browse the web without storing any local history and preventing tracking. It's a nice feature, I like it. You simply just right click on a file and select Open as Disposable VM. But it's more to mitigate a threat like malware and stop tracking than to protect against local forensic examination like you get with the Tails Amnesiac operating system. You can use an optional USB VM. This will protect the operating system from things like bad USB being plugged into the laptop or device. The USB VM sandboxes all the USB drivers and stack, protecting you from bad USBs. Data can then be carefully exported from selected devices to other app VMs. Application virtual machines, or app VMs. App VMs are the virtual machines used for hosting applications like your web browser, email client, PDF viewer, etc. Each app VM is based on an operating system template, the default being Fedora, the minimal template. Others include, as you can see here, Debian, Arch Linux, Ubuntu, Unix, that's the 2 gateway and workstation VM. Also you have Windows here, so you can run Office apps, Word, Excel, or the things you can run in Windows. To enforce these security domains, applications are placed in separate application virtual machines, app VMs. Here you can see examples of security domains: banking, personal, untrusted, work, etc. Because of this, what you see here, this application viewer, there is an illusion that they are running on the same machine, but they are in reality separate virtual machines. You could be running a untrusted browser on hackme.com and a browser for banking at the same time. Any exploit from the untrusted browser wouldn't affect your banking VM at all. And each security domain is labeled by a color, and you can see here each window is marked by the color of the domain it belongs to. So here is the yellow, which is personal, which you can see there. There is the green, which is work. So it's always clear, visible as to which domain a given window belongs to. They also allow for things like secure copy and paste operations between VMs, securely copying and transferring files between VMs, and secure networking between VMs and the internet. Qubes has inbuilt integration with Tor. The Unix gateway and workstation templates come with Qubes and is a great option for using Tor and preventing leaks. You get the benefits of Unix privacy and anonymity and the host security, isolation and compartmentalization of Qubes together, which is a very good solution. Hardware. Because of its design, Qubes has a level of resistance to malicious hardware, backdoored NICs, USB drivers, bad BIOS, disks and SATA controllers. Qubes also has some other security features, sort of added bonuses. You can split your GPG private key to help protect it, some functionality to enable that. And there is a PDF converter to make PDFs trusted effectively. And I'm sure there'll be other added security features as the OS matures. So all of this sounds great, doesn't it? So what are the downsides? Why might you not just go out and install this now? Well, the first one of the big problems with Qubes is lack of hardware support. I have a number of laptops, and in order to get it to work on my Sony Vaio, I had to flash the BIOS, which is a pretty scary prospect for most people, even highly technical people, as it can brick your laptop. To take full advantage of all the cool security features, you'll need a CPU that supports virtualization technology, including both Intel VTX or AMD V, which you can see here, and Intel VTD or IOMMU, which you can see here. Plus a BIOS with a trusted platform module to protect against the evil maid attack. You're also going to need a fast CPU and lots of RAM if you want to run a number of VMs. Another issue is with the manufacturers. They often make changes to the hardware of a computer or laptop or device throughout the life cycle of that laptop without notice, and yet it's still called the same model. And the features Qubes takes advantage of are not features normally advertised by a vendor. So you're not quite sure whether the laptop you're going to buy is going to support the features you need it to support. This is a clear barrier to entry for any new user and turns people away. I recommend the live USB to test Qubes to see if it will work on your hardware. If you think about getting a laptop, Then have a look at this hardware compatibility list for examples of devices that fully support Qubes or partially support Qubes. The list is growing and is actually much easier to understand now that they've cleaned up the list, because it used to be a bit of a mess. But it's actually pretty good now, and you can see quite clearly what works and what doesn't work. And there's also added commentary on what they needed to do perhaps to make it work. But notice this is community supplied, so it might not be 100% accurate. So there's actually quite a few in there. There's a lot more than there was last time I looked, which was a few months ago. And actually that's the model that I have with Qubes running on it. And yeah, actually as it says here, you had to flash the BIOS. Yeah, so I had to flash the BIOS on mine to get it working. But as you can see, there's quite a few that actually do work. And some of the ones on here are not that expensive. You can get sort of an older laptop around $150, $200, something like that. There's also a Google group for Qubes. That's useful for help on what hardware might work and getting your hardware to work. And I think I mentioned it before, it doesn't work in a virtual machine, or at least I've not been able to get it to work in a virtual machine. So you will need to install it on bare metal or try the live USB, live CD option. There is one current Qubes certified laptop, which is the Librem 13, which you can see here, which you can get Qubes pre-installed onto. This was a crowd-funded, privacy-focused hardware. I remember seeing it. This is where it was crowd-funded here. And you can go and buy them from here, but they're not that cheap. As you can see here, $1,499. But obviously that is because the laptop is niche built to be privacy focused and sourced to be privacy focused. Check that out if that interests you. But from the hardware compatibility list, you'll find laptops that are much cheaper if you really want to try and get Qubes working. Another issue to consider: performance and compatibility could be a problem with Qubes, especially if you're only going to have one device. You're not going to be able to run games and high demand software in virtual machines unless you've got a very, very powerful machine, or it's certainly not going to be as good as a native machine or the same native machine without VMs. So this will probably just be for work, personal, and a security laptop, not a performance laptop or performance device. So what are my general conclusions? Well, this is an operating system still in the early days, but with the right hardware offers some unrivaled security features for anyone technical enough to take advantage of them. It is not designed like Tails to prevent local forensic examination. It is for those most concerned about vulnerability exploitation. Although it does have disposable VMs, these are more to remove a threat than to mitigate local forensic examination. It is a platform for security and exploitation prevention and isolation. It is arguably the best security platform for hosting another secure operating system. Hopefully the hardware compatibility issues will get easier, and I think they will, and Qubes has got a bright future. I recommend you try it out, and I recommend you use it, especially if you have high security, privacy and anonymity needs. And to finish off, literally a few days ago of me recording this video, this has been released by the Qubes guys. This is tutorials on using Qubes, so check that out. They're also on YouTube as well. There's quite a few of them and they're quite good. So thanks to the Qubes team for a great OS. Keep up the good work.